Question for you, I managed to finally catch you live. My friend and I are considering net rollback on a custom little fighter we have, but we're not sure if it's worth diving into now. Any advice for beginning developers? In my personal opinion, if your fighting game does not have rollback online, it's not going to be worth people's time to play it. Because they'll have to go to... It'll be a frustrating experience one way or another. So if you want to go in with the full gambit of actually having netcode, do everything you can to get rollback working. But it might be easier to understand how rollback works before you get into that. Because otherwise you're left with delay-based netcode or you're left with parsec, and both delay-based netcode and parsec are terrible for fighting games at any distance. If you live in the same city and you've got your $100 billion Google Fiber 10 gigabit connection and you're playing with your next door neighbor, then parsec works fine. If you don't have that, or you have any considerable distance between you and the other player, parsec's not going to work fine. It's going to be very laggy, and it's not going to be a very good experience. And you also have uneven lag, so the host has no lag, and all the lag is on the opponent, and that's not really fair, and etc, etc. Although it's very easy to set up, the results are not good for a fighting game. But what I would probably recommend is to make a small rollback netcode demo to understand how netcode and rollback works first. Then you build your fighting game with those lessons that you learned in mind. And they're gonna be, here's the bullet points. Don't use floating point math. If you don't know what that means, you're gonna have to look it up. You wanna use fixed point math. Because floating point math, the TLDR there is doing a multiplication or division operation, or even an addition one sometimes, on a computer with decimal numbers, with a floating point decimal number. You're going to get a different answer on one computer than you are on another computer. And if your games have to be in 100% sync, that ain't good. That's an instant desync on every single mathematical calculation that you have. So you need to use fixed point math to make sure your math is consistent on all the devices that are being played on. Floating point numbers are completely inconsistent. You cannot trust them in any circumstance. Some people will tell you that you can. You can't. Don't use them. The amount of erroring that happens, the deviation on answers that you get, depends on your operating system, your processor, your motherboard can influence it. It's a nightmare. There's no way to guarantee that they're going to be the same on all platforms, especially if you do like, I want to play netcode between Windows and Android. Well, guess what? Windows and Android have different specs on floating point numbers, so that's going to influence your stuff. Don't use them. And you need to decouple your rendering code from your game code. So typically in a game, what happens is here, let me unpause it here. Actually, let me go to training mode. It'll be a little easier to explain. That way the timer's not going down and it's not pissing me off. Typically what happens when you render a game, the game updates, like where Ryu is jumping, the jumping code updates, and Ryu's punching, and the attack code updates, and we handle things like Terry getting hit and all that stuff. The animation is handled in the game update and all that stuff. But what you have to do is keep that separate from the actual visuals being drawn on the screen. So all the animation, all the data updates on the back end, and then phase 2 of the game update is painting that to the screen. It paints the backgrounds, it paints the characters onto the screen, it renders everything all there. When you do rollback, you have to be running the game 7 times the normal speed that the game would normally be running at, essentially. I would say that'd be around your minimum that you want to do. You want to be able to run the game 7 times the speed that it's normally at. And that's because you're constantly rewinding and catching up. When you do a rollback, it rewinds time and it updates the game behind the scenes, and it corrects the timeline by doing an update up to 7 times. And I think 7 is what MKX uses, and Injustice 2. That was their target. They wanted to have 7 simulation frames. And when I say simulation frames, that's data updates on the game. That's Ryu's jumping is updating, and his attacks are updating. All the stuff behind the scenes that has nothing to do with rendering the sprites to the screen. You know, it's an animation, sure. But the animation, the data of the animation says, we're using this sprite, and these hitboxes are loaded, and shit, I'll just show the hitboxes. We got these hitboxes loaded, and that's what the game is currently, the data side of the game. You have to be able to run that a bunch of times before it ever prints to the screen. If you integrate your drawing code in with your update code, it's going to take way longer to update the game, because then your update drawing during your rollback, and that's going to slow it down substantially. So keep those separate, completely separate. In Unity, that's a little hard. You have to do some big workarounds to get fixed math and to get the updates outside of all that. Now, Unity's rendering and their updates are separate, but their update does not allow you to call manually. So it updates its stuff, it updates the data, and then it will render, but you can't tell Unity, hey, can you update like 3 times for me, or 4 times, or whatever in a loop? You can't do that. It doesn't allow you to do that. As far as I'm aware, I have not found a way to do it. And I've read that it's not possible to force it to do that. So I had to make my own update code and keep all the objects I want in its own loop, and that's a whole other story. But the bottom line is you have to be able to call an update at any point in time. You have to be able to update your data without printing it to the screen. That's important. Because when a rollback comes in, again, it's going to say, hey, rewind 7 frames and update 7 frames on your data end. And that's how we correct the timeline. We insert the proper inputs, and we replay the game in a split second. In 1 frame, we replayed like 7 or 8 frames on the data end to correct. That's where you get those teleports from in rollback. It's correcting the timeline by going back in time and then fast forwarding in that split second. You have to be able to have an engine that does that. And yeah, like I said, when you use rollback on old games, like when they did it with emulated games, you know, it had to just render it because there was no separation between the rendering and the data update. Yeah, it's not easy, but if you can get it to work, it works. Yeah, so like when they did rollback on emulated games, like the Samurai Showdown collection and all that, they didn't have a choice. They had to make it fast enough to play the game at like 7x speed, including the rendering. But since they're such an old game, it's fine. You know, there's enough horsepower to push that kind of thing. You think of like a fast forward button on emulators. You know, you can run the game several times the speed that it normally is because the hardware now is so good. But if you're making the game and you're in charge of the coding, you want to avoid that at all possible. You do not want that to happen because it's going to be an efficiency trap. It's going to kill your game. And the faster and the better that it works, you know, people with lower end computers can play it. Or for mobile, it's very important for mobile because mobile devices aren't really the most high powered things out there. So you have to keep that in mind. That aside, let's see. So I went over the fixed point versus floating point numbers. I went over the rendering and the update loop. I mean, those are really the big ones, I think. You have to be able to update on demand whenever the rollback engine says, hey, I need you to update, you need to update. Well, so like GGPO, if you go with using GGPO, you check in with it and it's like, yeah, I'm gonna hook into your game and I'm gonna control it now. So whenever GGPO says jump, you jump, you know, metaphorically. If it wants an update, you have to do an update. If it wants to load a state, you load a state. And it kind of takes control of that. And your game needs to be able to respond to those commands appropriately. So I guess to touch on a little bit more about the fixed math thing, that the goal of the reason why you need to have those accurate calculations, because your game needs to be in sync. And the word that we use to describe keeping them in sync is essentially determinism. Deterministic means if you set up all the data the same way and you play the game with the same inputs from the controller, it will be exactly 100% the same every time. Think of it as a replay function. If you have a replay function, you're just saving the controller input. Oh, on this frame he was pressing this button, on this frame he was holding back, whatever. You save that log of inputs, and if you play it back, your game needs to play exactly the same way every time on every different computer, every different platform, every different operating system needs to be 100% the same. Because when you do rollback netcode, you send the controller data. You don't send anything else. Because if you program the game properly, if your game is deterministic, that's all you need. You rewind the game, you plug in the input from player 2, and you play the game. When you update the data, it should be the same result every single time. And that's where the fixed math comes in. You need it to be 100% deterministic on all your gameplay stuff. If you have like HUD stuff, it doesn't need to be deterministic. It's just display data. If you have, in fact, most of the graphics don't really need to be deterministic. It's really the data end. It's the hitboxes. Where's this hitbox at right now? What's its position? What did it overlap? You know, when I press this button, that animation needs to load exactly on point. The hitboxes need to be where they need to be 100% of the time, every time. You know, that kind of stuff. But if you have a character in the background in the stage doing their own little animation, you don't need to worry about that. That doesn't need to be deterministic. All your gameplay needs to be deterministic. And that's hard. That's not easy. That does take a bit of considerable thinking to make sure you have that right. And I'm working all of that out now, where Unity's engine is not deterministic at all, 100% unreliable. It uses all floating point numbers, and I'm reprogramming Unity, essentially. Not the engine, not reprogramming the engine, but I'm programming components to work in Unity that have fixed point math. So I'm making my own animation system that acts like Unity's, but it's with fixed point numbers. That's what I'm doing right now. That's the step I'm on. I've got the positioning of objects correct. I've got collisions that are deterministic. But I'm working on animation now. And it's rough. It's taken a long time. I started doing these deterministic updates in January 2020. And I'm still working on it. So when people ask me, hey, would you recommend making a fighting game in Unity? I don't know yet. I actually don't know if I would recommend that yet. This has been a lot of work to get Unity to do what I want it to do. And actually, I can show this. I don't know. I'll just bring it right up. Here, deterministic Unity engine. I have a working rollback demo. Let's see, this is the animation one. So if I play the animation here, now Unity's animator can animate, oh, hold on, I gotta refresh my, there we go. Unity's animator can animate basically everything. It animates numbers essentially. So when you have the animation here, I'm actually changing the numbers on these fields, on these components. And what I'm doing is I'm taking Unity's animation clip and I'm deconstructing it into a fixed math version of that. And then I'm playing that fixed math version of the animation clip. And you can see it here calculating all the numbers to update this component with. And it updates the Boolean and all that. And it's all based on this animation here. So see, these fields are animated with Unity's animator. And then I just, again, I deconstruct that here. I take the animation clip and I deconstruct it into all of its data components and do all that stuff. Reaper, what? What are you singing for? What? I don't know if you can hear the chicken. She's sitting on the back of my chair, making little humming noises or something. And it's not complete yet, but yeah, it's getting there. And that's the basic tenets of Rollback Netcode. Oh, and the save and load state. I mean, I mentioned it, but just to put it at a point, you have to be able to save the game state and store it and then load it at some point. You know, that's how it rewinds time. It saves the data on your data end every frame, and then it says, and GGPO's like, hey, I need you to go back to frame 150. And so you pull data for frame 150, you load your state into your data end, and then it's going to tell you to update however many frames it needs to go. And that's how it goes back in time by loading the state, and then it resimulates the data end up to the current time. And that's how the rollback occurs. So you need save state and load state, and it's time consuming. I wouldn't say that was the hardest thing to do, but I'm also running into that operation is really slow, and I'm trying to find ways to optimize that. So I can show you the full thing here. This is just the animation test. I got it on its own so that I can work on it on its own, but here's the rollback test. Do the light version. So here, it's doing one frame of rollback. Let's see, we're in VSync, right? Let's turn VSync off. I'm getting 280, 300 frames per second, 250, 300. And here's all the stats. It's doing one rollback frame. Each data update is taking an average of 1.16 milliseconds. So we can increase the amount of frames there. Our target frame is 1.5 milliseconds. Our loading is 1.5 milliseconds, average 1.7. Our saving is 0.67. That actually got optimized really hard this last week. I did a big optimization to save state. So the total rollback time here of one rollback frame is 3.5 milliseconds on average. GGPO is free now. It used to be something you paid for. Yeah, no problem. Yeah, I was gonna say, save the link to this VOD, and you'll have it here. I don't know, maybe I'll make it a segment and upload a clip or something. I think people would find it interesting and informative at least. Well, we can crank this up. So if I go to my rollback test, we're gonna do, let's see, rollback in editor. Can we go to 4? What if we do 4? Yeah. All right, look, in the editor, everything's a little slower. So you gotta take that with a grain of salt. So I'm doing 4 rollback frames now. And you see, I'm moving Ryu, and you do not see any skipping, any jittering, even though we're doing 5 updates every frame. It's rolling back, it's loading the state every frame, and it's doing 5 updates for every frame that you see drawn. So it's doing 5 data updates. Going back in time 4 frames, and then doing 5 data updates. And so the 4 rollback frames plus 1, and the plus 1 is your normal timed update. And you see everything staying in sync. Everything looks good. Nothing looks crazy. The animation here is spinning right. You don't see any drops. You don't see any stuttering. No freakouts. And so that's what I'm doing. Now the animations here are not deterministic. They are getting rolled back, but they are not 100% deterministic because it's using Unity's normal animator, which is not deterministic. But that's why I'm developing the deterministic version. But that one's turning into a real chore. So I guess that's the basic tenets of it. I mean, you can get into the subtopics of each of those categories. You know, there's a whole mindset about how to save data and what data to save and what data to omit, and how you want to build your system to determine what's important and what's not, what gets rolled back and what doesn't get rolled back. You can go on for hours in each one of those topics, but those are the basic things that you want to look out for. You want deterministic. You don't want to use floating points. You want to use fixed points for things that are important. When you render to the screen, you're going to use floating points. You know, that's fine because it doesn't matter. The visuals have nothing to do with the gameplay being deterministic. You have to think of what needs to be accurate and what doesn't really have to be accurate. Let's see. Also, yes, people would love to hear that. I come at the tail end, but hearing people talk about rollback is always interesting. Yeah, all right. I'll probably make a clip of this then. So, I don't know. I hope you can actually read the text over here. It's a little small. But what I was pointing out here, these are all the stats. So I got my frames per second. Run ahead frames. That's another thing that you can do. Once you have rollback, you can do run ahead. And run ahead is another lag reduction technique where you update the game more times than you need to. Now it can get really weird. I probably won't, you know, I'm not going to get into run ahead too much. But think of it as reverse rollback. It runs the game ahead a couple of frames, 1 or 2 frames, so that when you press a button, you'll see. I actually pressed the button and it was still going over here. When you press a button, you'll see a few frames into the future. What the result that you'll see on screen is actually ahead a couple frames of current time. And for fighting games, I think Fightcade uses this. And because, like, the input lag, whenever you emulate something, you're going to get some input lag. And if you do a run ahead, you'll get a small visual jitter, but it will feel more responsive because you'll see the result of what happens faster by 1 or 2 frames. Again, that's a little out of the scope of this, but if you have rollback working, it is trivial to add it. Like, I added it in like 2 minutes once I had the rollback working, because you can update as many times as you want. Now, you can update the data without having to update the visuals. And so I can say, hey, you know what? Just update 1 more time. So you do your 4 rollback frames, you do your main update. Let's update just 1 more time, and now you have run ahead. And what'll happen is it will just load the state again anyway next frame and continue on. So, you know, you keep everything in sync anyway. That's really cool, but that you can look up better examples of that. And it's really hard to describe it in English without actually seeing the result of it. But yeah, so hopefully that helps out. I mean, you got kind of like a baseline idea of what to look for and where to go. So those are the big things: your determinism, save state, load state, and keeping your data update separate from visually rendering the game to the screen. I'd say those are the 3 pillars. So yeah, we'll cut that into a segment. We'll upload that separate. But yeah, obviously I leave the VODs up. They're only up for a limited time on Twitch, but if you're on YouTube, so if you look Game Dev Scrubs up on YouTube, they're all there. I keep them saved every week. So yeah. Alright, cool. Cut segment. It's the end of that. So hopefully that was understandable and not too complicated or convoluted. It's kind of a big topic, so it's a little hard to be basic about it, but I think that that should be a good primer. But if you have any questions, then certainly fire them off.